Okay, this is part 2 of factoring polynomials. We're going to get into some special products. Z squared plus 8z plus 16. Z squared is a perfect square. I'm thinking, and I know 16 is a perfect square, so it falls into that. That is equal to a plus b squared. Now, we have to check. A is equal to, let's do it this way. I think a squared is equal to z squared, and I think b squared is equal to 16. So it means a is equal to z, b is equal to 4. And then what is 2ab, just to make sure? That's 2 times z times 4, which is 8z. So that checks. That is indeed how it factors. So again, a is z, b is 4 squared. That's my answer. I've already checked it. We're good to go. We do the same type thing here. This looks like a perfect square. It looks like a perfect square because 9's a perfect square, x squared is a perfect square. So I have to check to make sure it matches. If I say a squared is equal to 9x squared, that means a is equal to 3x. If I say b squared is equal to y squared, that means b is equal to y. Now I have to check 2ab. 2 times 3x times y is indeed 6xy. That works because that is the same. So it factors the way I think it does. How does it factor? A minus b squared. So that's what we write it as. A is 3x, y is b, so 3x minus y squared in parentheses. This looks like my difference of squares. Difference of squares follows the form a squared minus b squared. How do I know it is? Well, 36 is a perfect square, m squared is a perfect square. 49 is a perfect square, n squared is a perfect square. So, that tells me a squared is equal to 36m squared. So a is equal to 6m. B squared is equal to 49n squared. So b is equal to 7n. So I can now factor this as 6m minus 7n. Okay. Oh, wait, let me go back to the beginning. How does this one factor? You can write it two different ways. A plus b, a minus b, or switch them around. A minus b, a plus b. So I factor this. A plus b, a minus b. That's your answer. I've already checked it. It makes sure it works, and so it works. Now, most of these down here are either difference of squares or perfect square trinomials. We always check for GCF first. I'm going to do this last example, which I don't think you have a problem like this, but I'm going to show it to you so in case we see it later. Look for your GCF. In this case, it's 2a. So when I pull the 2a out, I get 2a, and I'm left with a to the 4th minus 81. Now, that looks like the difference of squares, a squared minus b squared. Okay, the same variables are going to throw you off, but I know, and we should all know, that a squared squared is equal to a to the 4th. Okay, that means b squared is equal to 81, or b is equal to 9. So I'm going to factor this one last bit as 2a squared plus 9, a squared minus 9, and guess what? This shows up again. This is a hard problem with lots of steps. So it factors one last time. So I did a GCF 2a, and then I did a difference of squares of a to the 4th minus 81 as a squared plus 9, a squared minus 9, and now I've got a squared minus 9 factors out like that. So again, to sum it up, GCF is the first thing I checked for. Always check for GCF. It's how you get these problems right. After that, look for special product. Difference of squares. A to the fourth is a perfect square. 81 is a perfect square. A squared plus 9, A squared minus 9. A squared minus 9 is the difference of squares. A plus 3, A minus 3. Okay, so we'll pick these up in class and go from there.